When you look at the rusting of iron or the burning of magnesium, it's pretty easy to tell which reaction occurs at a faster rate. Usually you can determine the rate of reaction by the appearance of products or the disappearance of reactants. But what's actually going on at the atomic level? It's all to do with the collision theory and the kinetic energy of particles. All particles in a substance are always in some sort of random motion. Chemical reactions occur when these particles collide with sufficient speed and in a correct orientation. Let's track a few of these particles. If these two particles collide, their size, speed, and angle of collision will determine whether they bounce off each other or react together. Sometimes particles can briefly stop moving due to a collision as their kinetic energy can be absorbed by the very particle they bumped into, and then they move with a greater speed. But this is only momentarily, as another collision will occur due to the other moving particles. And so the process continues. Therefore, the rate of reaction depends on very precise collisions occurring in a given time. One way to ensure more collisions are occurring is to just have more particles participating, that is, increasing their concentration. These particles are in the same phase, that is, gas or liquid, and will end up having a greater probability of colliding in the precise manner to undergo a chemical reaction. With gases particularly, increasing pressure like cramming more particles in the same space or reducing the volume of the container will increase the probability of collisions. Temperature can also affect this rate. Generally, there's a funky bell curve of a graph that displays a range of kinetic energies for substances involved in a chemical reaction. The x-axis demonstrates the range of kinetic energies, and the y-axis shows the number of particles which possess that particular kinetic energy. So at a particular temperature, it may be that only a small proportion of particles have the required threshold energy, that is, the activation energy, to proceed with the reaction. When these particles collide, they have enough energy, orientation, etc. to break bonds so that new ones can form. When temperature is increased, so does the average kinetic energy of the entire sample, which means that there is a greater proportion of particles with sufficient energy to participate, although there will still be a range of energies for all the particles.